This is one of the important subject for GATE examination. The subject will carry around 15 to 18 marks in the examination. We can divide the subject into different topics so that it is very useful for reading, as well as from which topic we can get more marks. So we can divide into some parts. First one is basics. In this basics, we will study about vector analysis, coordinate system, electrostatic fields, magnetic fields, so all these things we will study in basic part. In all of these basics we can expect 2 to 4 marks from this basics. Next part is Maxwell's equations, and uniform plane wave propagation. This is one of the important topic. We can expect 4 to 6 marks from this. Next one is transmission lines. Waveguides, antennas. Combinedly, we can expect around 8 to 12 marks from these three: transmission lines, waveguides, and antennas. So we have to concentrate more on Maxwell's equations, uniform plane wave propagation, and transmission lines, waveguides, antenna part. Most of the questions will come from these two topics. Come to the textbooks. So which textbooks we can refer? The first one is Elements of Electromagnetics. By M.N.O. Sadiku. This is one of the important book, Matthew N.O. Sadiku. Second one is Electromagnetic Waves and Radiating Systems. By Jordan and Ballman. This is one of the standard book, all of you know very well. The third one is Engineering Electromagnetics by William Haight and J. Buck. Engineering Electromagnetics by William Haight and J. Buck. This is also one of the important books. For problems, that is especially for problems, we can refer Electromagnetics by J.A. Administer. This is a Sham series book. So we can solve more problems from this Sham series book. Of course, these books, in these three books also, there are plenty of problems which covers basic theory also in a very well manner. So we can refer these 4 books. Of course, you can refer any other reference book also, but these 4 books will cover the entire theory and problems in a good manner. So this is the analysis of the subject. Transmission lines. Very important topic. The basic purpose of a transmission line is for transmission of energy. From one point to another point. That is, suppose we have a source here, suppose we have a load here, so I want to transmit energy from source to load. So these source to load are connected with the help of lines known as transmission lines. So this is the basic purpose. So transmitting energy from source to load, that is from one point to another point. So these are transmission lines. Actually, we can transmit the energy by using guided structures. So what is the meaning of this guided structures is, the energy is guided in a particular direction from source to load. So the guided structure may be either transmission lines or waveguides. There are different types of transmission lines are there. Because in this topic we will mainly concentrate on transmission line, and in the next topic we will discuss waveguide part. The basic one is a two-wire line. The shape of the two-wire line is like this. That is, two parallel wires are separated by a distance. So we can call it also as a parallel wire transmission line. The next one is coaxial line. So there is a conductor. So inner side another conductor. So this is outer one, this is the inner one. Some microstrip lines, that is the shape of a microstrip line is like this, which we have a small strip, conducting strip. So generally this is for high frequencies. Here for our discussion we will use this two-way line or parallel transmission line. That is, two lines are separated by a distance, two parallel lines. We will discuss basic principles of transmission lines. Here we are considering a parallel wire line. So a parallel wire line having two wires separated by a distance. Suppose the length is L. This is called length of the transmission line. Separated by a distance S. Where S is the distance between the two transmission lines. So some input or source input or source, some output or load. That is, source and load are separated by line. So we have to transmit energy from source to load with the help of transmission line. So connected like this. So here some voltage, input voltage called Vs. Similarly, we will get some output voltage. Some input current, like similarly suppose Is input side, output side some IR output current, load, consider some like having a characteristic impedance of Z suffix R. So here ZS. ZS means input impedance. Input impedance. How we can define this is, input impedance is the impedance that transmission line presents at its input terminals to the source of input voltage. That is, input impedance is nothing but the impedance when we look into the transmission line. So if you look into the transmission line, the impedance is named as input impedance. So this is the basic structure of a transmission line. So the basic parameter, Vs input voltage, Is input current, Ir output current or load current, suppose some voltage Vr, output voltage, L length, S distance between the two parallel lines. So this is the basic structure of a transmission line and basic terminology. And input impedance is nothing but the input seen when we look into the transmission line from input side. Equivalent circuit. Of a equivalent circuit of a transmission line. So the equivalent circuit is like this. The equivalent circuit looks like this. R, L, R and L are in series. This is G, C, this is in continuation. Again R, L in series, G and C in parallel. So this is length L. So in the length L, the parameters are distributed. So transmission line is a distributed network. Suppose the length of this is X. The parameters are repeating for every X distance, then we can say that it is a uniformly distributed line. Uniformly distributed line. Suppose if the parameters are not repeating for every X distance, obviously it is a non-uniform distributed line. Generally, for our discussion, we will consider the line is a uniformly distributed line.